Once again, we know that sine theta is going to be positive, so we only have to worry about the positive root of 225 over 289. That gives me an answer for sine theta equaling 15 over 17. Well, immediately, if we know sine theta is 15/17, we know that the cosecant theta is the reciprocal, or in other words, 17/15. And to finish it off, we just need to find cotan theta, which we remember we were given tan theta at the very beginning. So cotan theta is equal to the reciprocal, or in other words, -8/15. So we just found the 6 trigonometric functions using Pythagorean identities, reciprocal identities, from knowing just one of them. Well, now I would like for you to use the Pythagorean identities and the reciprocal identities to find the 6 trigonometric values in the next problem. Find all 6 trigonometric function values for angle theta if the tangent of theta is equal to the square root of 3 and theta is in quadrant 3. Pause the video while you work on this problem, and when you're finished, restart the video to check your solution. Since theta lies in quadrant 3, the tangent and its reciprocal cotangent will be positive, while all the other trig functions will be negative. So here we have tangent theta equals square root of 3. Well, the reciprocal cotangent would be 1 over the square root of 3. Rationalizing that denominator, we would get square root of 3 over 3. What about finding the secant of theta? Use one of the Pythagorean identities that says 1 plus tangent squared theta equals secant squared theta. And that means 1 plus the square root of 3 squared equals secant squared. Square root of 3 squared, of course, is just 3. So we have 1 plus 3, which is 4, equals secant squared theta, which means the square root of 4 equals secant theta. And again, in this particular case, we know that it's going to be negative. So we have -2 equals secant of theta. Well, once we know that secant theta is -2, we know the cosine is its reciprocal, -1/2. To find the sine of theta, we can now use the Pythagorean identity that relates cosine squared and sine squared. So sine squared theta is equal to 1 minus cosine squared theta. And cosine theta is -1/2. So sine squared theta is 1 minus -1/2 squared. -1/2 squared is positive 1/4. 1 minus 1/4 is 3/4. So sine theta is negative the square root of 3/4. Well, negative the square root of 3/4, we can simplify the bottom. The square root of 4 is just 2. So the sine theta is negative square root of 3 over 2. Once we know sine theta, we know the cosecant is its reciprocal, so it's -2 over the square root of 3. Rationalize that denominator, and we get -2 square roots of 3 over 3. Let's look at an application problem. Suppose the uphill grade of a highway can be modeled by the line y equals 3/100x in quadrant 1. A, find the grade of the hill. B, determine the grade resistance for a gravel truck weighing 25,000 pounds. To do this problem, let's draw a picture of this grade. We have a hill which has a y equals 0.03. In other words, 3/100ths is the slope of this. So for every 3 feet that it goes up, it travels 100 feet horizontally. And this would be the truck, going up the hill. All right, so now, when we talk about the grade of the hill, the grade is the percent of that slope. In other words, it's 3/100, which of course we know is 0.03, which is 3%. So the grade of the hill is 3%. Well, what about determining the resistance of this truck? The truck is 25,000 pounds, and it's attempting, or it is going up a hill with a grade resistance of 3%. So what that gives us is a resistance using the formula that R equals W sine theta, where, of course, W is the weight, 25,000 pounds. Theta is the angle of the road, and R is my resistance. So we know that R is equal to 25,000 pounds times the sine of theta. Well, the sine of theta, this is a right triangle. And the sine of theta is going to be the opposite over the hypotenuse. Well, that means we have to find the hypotenuse, right? Because we have the side opposite, we have the side adjacent. So the hypotenuse, which I will label as R, little r, is equal to the square root of 100 squared plus 3 squared. That's equal to the square root of, 100 squared is 10,000 plus 3 squared is 9, so the square root of 10,000, 9. So sine theta then is 3 over the square root of 10,000, 9. So we have resistance equals 25,000 times 3 over the square root of 10,000, 9. When you work all of that out in your calculator, you'll find the resistance is equal to approximately 750 pounds. All right, great work in today's lesson. Now, remember, understanding trig functions and their identities is essential in the study of angles and the sides of triangles. The functions are tools used to solve problems involving lengths and angles. Be sure and work the exercises that your teacher assigns, and we'll see you next time.